Namaste everyone. In this video we'll be solving a problem in kinematics. We have a particle which is moving under constant deceleration in a straight line. So I've taken 3 dots in the straight line. So it's covering a distance of 20 meters. 20 meters it's covering in the first 2 seconds. And then it's covering under a distance of another 40 meters in the next 5 seconds. So the distance and time between these 2 points is 5 seconds. So now we need to find the distance that it will cover in subsequent 3 seconds. That means after our previous point, this one, after 3 seconds. So 3 seconds after our previous point, we need to find the distance that it will cover. Fine. So just so that we understand this perfectly, let me give some names to all of our points. So here the distance between A and B is 20 meters. Time taken for that is 2 seconds. Distance between B and C is 40 meters. And the time taken for this distance is 5 seconds. And distance between C and D is what we need to find. The time taken for that has been given to us as 3 seconds. So okay, so here we can write it as AB equals to this, BC equals to this, and CD distance we need to find. The time, let's call it as T1, T2 and T3. Okay, so since he is telling that the deceleration is constant, we can apply all the equations that we have for constant acceleration. The first of them being V equals U plus AT, second being S equal to UT plus half AT square, and third being 2AS equals V square minus U square. So here we need a relation between distance and time. So the second equation is the best one for us to use. So let's take this equation and start using it. So the distance traveled is from A to B. So let's call it as AB. The initial velocity, we don't know its value. Time taken for that is 2 seconds. So let me substitute 2 seconds over here. And acceleration is not known. Let's keep it as it is. And again, once again, time taken is 2 seconds. So when we simplify this equation, we get the value of AB we know. So let us substitute it as 20. We get 2U, and one value of 2 will cancel, and we'll just get 2A. Simplifying it further, we get 10 equals U plus A. So let us call this as equation number 1. The next motion that we'll take up is A to C, not B to C, fine, because we don't know the initial velocity at this point. We know the initial velocity only at this point, so that's the only variable we want to retain. And so the next equation we'll apply is from A to C. So the distance is A to C. Initial velocity remains as U. When you are taking time, we have to take the total time. So total time for this point to this point is 2 plus 5, that is 7 seconds. Right? So 7 is what we need to substitute here. Then half A is not known, 7 square again. Let us again simplify this. A to C, again the total distance we have to find. So 20 plus 40 we have to substitute. That comes out to be 60. So 60 equals 7U plus 49A divided by 2. So this is our equation number 2. Now we can see that these two equations are equations in 2 variables, which you can solve either by substitution method or by directly the other method, the cancellation method. So let's just go for substitution. So from equation 1 we get something like let's substitute for A. So A will be equal to 10 minus U. So let's just substitute this. So substitute in equation number 2. So let's substitute that in equation number 2. So equation number 2 is 60 equals 7 times U as it is, plus 49 by 2, and in place of A we are substituting 10 minus U. So now in this equation U is the only unknown and we can find its value. Right, so U is the only unknown. So 60 equals U, if you take common, we're getting 7 plus Okay, so we can just take that common. So this value will go on the other side. So minus 49 times 10 over 2, that will be equal to, now u can be taken common. What remains inside is 7 plus 49 into 10, sorry, that has gone, and we'll get minus 7 minus 49 by 2 inside. Fine. So this we will be able to get the value of u. So let's find this. So 60 minus 49 into 10 divided by 2, and this whole value we'll have to divide by 7 minus 49 by 2. So if you have the modern scientific calculator, we'll be able to feed the equations exactly like this, and we'll get the answer. We're getting u value as 10.57, 10.57 meters per second. If we substitute the value of u in this equation over here, we get a equals 10 minus 10.57, which gives the value of a as negative 0.57 meters per second square. So this is our acceleration. Now using these values of u and a, we will be able to find the value of CD. Now how to find the value of CD? We know CD is equal to AD, the complete distance A to D, minus A to C. So this is how we need to use it. So now the distance AD, for AD again we'll have to use this same equation. It will be UT, okay, UT, so this T is going to be different. Let's find the value of AD and AC separately. Okay, so AD will be UT, so okay, UT plus half AT square. So what's the value of u value we found out, that is 10.57, and time taken, we'll have to take the total time taken, so that is 2 plus 5 plus 3, that total it comes out to be 10 plus half into negative 0.57 into 10 square. Fine. So that's the value of AD, that's the value of AD. And coming to AC, we'll have to again apply the same equation. Initial velocity remains the same, that is 10.57. The time taken for A to C is 7 seconds, and plus 1 by 2 minus 0.57 is the acceleration, and again the time taken is 7 square. So let's find out these two values, and when we substitute them both here, we will get the value of CD that is asked. So let's go ahead, do the calculations. Okay, so we have 10.57 into 10. This is going to be minus 0.57 into 10 square whole divided by 2. So that's giving us 77.2. And let's find AC next. To find AC, it's going to be 10.5 into 7, okay, minus again 0.57 into 7 square whole divided by 2. So that's giving us 59.5. So 59.5. So both are going to be in meters. So when we substitute them both here, we get the value of CD as 77.2 minus 59.5, which comes out to be 77.2 minus 59.5, 17.7. So this here is our answer. So that here is our answer. So this is the distance traveled between the next 3 seconds. So I hope you have understood this particular problem. The next one will take up another question. Thank you.